Genesis of tetanus. In this experiment, we will learn about a phenomenon called tetanus. Principle. If a muscle is stimulated at high frequencies, there is sustained tonic contraction of the muscle. This is called tetanus. We set up the nerve muscle preparation like the muscle twitch experiment. The interrupter is set to give 5 interruptions per second. So there will be 5 stimulations of the nerve per second. The nerve is stimulated 5 times per second and the contractions are recorded. Now we change the setting of the interrupter to provide 10 interruptions per second. We record the contractions on the kymograph. We go on increasing the frequency of interruptions. This is recorded on the graph. Then we examine the recordings and analyze them. The recordings look something like this. You can see the frequency of stimulation increasing in every graph. In the first graph, we can see that the amplitude of the response increases with each stimulus. This gives the graph a staircase-like look. Thus, it is called the staircase effect or the treppe effect. Treppe is a German word for staircase. The treppe or staircase effect is the progressive increase in force of contraction when the muscle is stimulated repeatedly. Treppe is seen in skeletal, smooth, and cardiac muscles. Now, let's take a look at the third graph. This graph shows a state called clonus. Clonus is a state of partial tetanus. This is experimental clonus where the muscles show incomplete relaxation in between contractions. The fourth graph shows tetanus. Tetanus is a state of sustained contraction. A muscle in tetanus remains in a state of tonic contraction without relaxation. When a muscle is stimulated in rapid succession, the new stimuli fall in the contraction phase of the previous stimulus. The contractile processes of the muscle do not get time to relax in between contractions. Eventually, the individual responses fuse and lead to a sustained contraction, which is called tetanus.